And finally, how it's implemented. We will look at 3 problems that virtual memory solves: not enough memory, memory fragmentation, and security. In the old days, computer memory was expensive and computers didn't have as much RAM as today. For instance, most CPUs could support up to 4 GB of RAM, but it was common for computers to have only 1 GB of RAM, or even less. Why could CPUs support only up to 4 GB? That's because registers could store 32 bits and could access up to 2 to the power of 32 bytes of memory, which is 4 GB. And this is what every program could do in theory. Modern CPUs, on the other hand, have 64-bit address space, but we will use 32 bits for examples in this video because the numbers are easier to work with. Our computer has only 2 GB of RAM in this example, which is 31-bit address space. So what happens when a program tries to access the first few bytes? That's not a problem. But what happens when the program tries to use more than 2 GB of memory? The program will crash because there is no memory to access. This is why programs used to crash in the 1950s or so. Now let's look at the second problem. Let's say that we have installed 4 GB of RAM and we have 3 programs. A video player that runs a movie and needs 1 GB of RAM, a video game that needs 2 GB of RAM, and a photo editing software that also needs 2 GB of RAM. If we run programs 1 and 2, they can fit in memory. They use 3 GB, leaving 1 GB free. If we close the video player, the memory usage is now 2 GB and there's also 2 GB of free space. We should be able to run the photo editing software, but we can't because the memory is split, even though there's enough space in total. This is called memory fragmentation. Why can't we split our program across the memory, you may ask? We could, but writing such programs would be very hard. If we have a global array of elements, we wouldn't be able to access any element using indexes if it was split across 2 memory chunks, for instance. We would have to implement some kind of indirection, and as you'll see later, this is what the virtual memory is. Let's look at the third problem. We've said that each program can access any 32-bit address, so what happens if 2 programs try to access the same memory? For example, say that both programs write some value to the address 64. A video game that stores the player's current health, and the music player that writes the remaining song duration. When the song finishes, the music player writes 0 to this address, and if this is also the player's health, you would be dead and it would be game over. That would be very annoying, because these 2 programs are corrupting each other's state. So to summarize, if all programs have access to the same 32-bit memory space, they can crash if they access invalid memory addresses because the computer has less than 4 GB of RAM. They can also run out of space if there are multiple programs running due to the memory fragmentation, or they could also corrupt each other's data. The key problem here is that programs have access to the same memory space. So, if we can give each program its own memory space, then we might be able to solve these problems. The memory space assigned to each program is called virtual memory, and every program has its own virtual memory that doesn't overlap with other programs. But this means that we have to map each program's virtual memory space to RAM space. We will
Earlier this year, I was contacted by the Computer History Museum asking if I could help make a short explainer video for this exhibit they're doing about large language models. If you're a regular viewer, you'll know that I was also making a fair bit of material to visualize this topic anyway. More importantly, this is a museum that I really love, so this was a very easy yes. At first, I thought this was just going to be an abridged version of the more detailed explainers that I was already making, but ultimately it proved to be a really satisfying outlet for emphasizing some of the more important ideas that those more technical explainers may have glossed over. I'm very curious in the comments if you think this is useful as a lightweight intro to share with others in your life curious about large language models. But without further ado, let's dive in. Imagine you happen across a short movie script that describes a scene between a person and their AI assistant. The script has what the person asks the AI, but the AI's response has been torn off. Suppose you also have this powerful magical machine that can take any text and provide a sensible prediction of what word comes next. You could then finish the script by feeding in what you have to the machine, seeing what it would predict to start the AI's answer, and then repeating this over and over with a growing script completing the dialogue. When you interact with a chatbot, this is exactly what's happening. A large language model is a sophisticated mathematical function that predicts what word comes next for any piece of text. Instead of predicting one word with certainty, though, what it does is assign a probability to all possible next words. To build a chatbot, what you do is lay out some text that describes an interaction between a user and a hypothetical AI assistant. You add on whatever the user types in as the first part of that interaction, and then you have the model repeatedly predict the next word that such a hypothetical AI assistant would say in response, and that's what's presented to the user. In doing this, the output tends to look a lot more natural if you allow it to select less likely words along the way at random. So what this means is even though the model itself is deterministic, a given prompt typically gives a different answer each time it's run. Models learn how to make these predictions by processing an enormous amount of text, typically pulled from the internet. For a standard human to read the amount of text that was used to train GPT-3, for example, if they read nonstop 24/7, it would take over 2,600 years. Larger models since then train on much, much more. You can think of training a little bit like tuning the dials on a big machine. The way that a language model behaves is entirely determined by these many different continuous values, usually called parameters or weights. Changing those parameters will change the probabilities that the model gives for the next word on a given input. What puts the large in large language model is how they can have hundreds of billions of these parameters. No human ever deliberately sets those parameters. Instead, they begin at random, meaning the model just outputs gibberish, but they're repeatedly refined based on many example pieces of text. One of these training examples could be just a handful of words, or it could be thousands, but in either case, the way this works is to pass in all but the last word from that example into the model and compare the prediction that it makes with the true last word from the example. An algorithm called backpropagation is used to tweak all of the parameters in such a way that it makes the model a little more likely to choose the true last word and a little less likely to choose all the others. When you do this for many, many trillions of examples, not only does the model start to give more accurate predictions on the training data, but it also starts to make more reasonable predictions on text that it's never seen before. Given the huge number of parameters and the enormous amount of training data, the scale of computation involved in training a large language model is mind-boggling. To illustrate, imagine that you could perform 1 billion additions and multiplications every single second. How long do you think that it would take for you to do all of the operations involved in training the largest language models? Do you think it would take a year? Maybe something like 10,000 years? The answer is actually much more than that. It's well over 100 million years. This is only part of the story, though. This whole process is called pre-training. The goal of auto-completing a random passage of text from the internet is very different from the goal of being a good AI assistant. To address this, chatbots undergo another type of training, just as important, called reinforcement learning with human feedback. Workers flag unhelpful or problematic predictions, and their corrections further change the model's parameters, making them more likely to give predictions that users prefer. Looking back at the pre-training though, this staggering amount of computation is only made possible by using special computer chips that are optimized for running many operations in parallel, known as GPUs. However, not all language models can be easily parallelized. Prior to 2017, most language models would process text one word at a time. But then, a team of researchers at Google introduced a new model known as the transformer. Transformers don't read text from the start to the finish. They soak it all in at once, in parallel. The very first step inside a transformer, and most other language models for that matter, is to associate each word with a long list of numbers. The reason for this is that the training process only works with continuous values, so you have to somehow encode language using numbers, and each of these list of numbers may somehow encode the meaning of the corresponding word. What makes transformers unique is their reliance on a special operation known as attention. This operation gives all of these lists of numbers a chance to talk to one another and refine the meanings that they encode based on the context around, all done in parallel. For example, the numbers encoding the word bank might be changed based on the context surrounding it to somehow encode the more specific notion of a riverbank. Transformers typically also include a second type of operation known as a feed-forward neural network, and this gives the model extra capacity to store more patterns about language learned during training. All of this data repeatedly flows through many different iterations of these two fundamental operations, and as it does so, the hope is that each list of numbers is enriched to encode whatever information might be needed to make an accurate prediction of what word follows in the passage. At the end, one final function is performed on the last vector in this sequence, which now has had a chance to be influenced by all the other context from the input text, as well as everything the model learned during training, to produce a prediction of the next word. Again, the model's prediction looks like a probability for every possible next word. Although researchers design the framework for how each of these steps work, it's important to understand that the specific behavior is an emergent phenomenon based on how those hundreds of billions of parameters are tuned during training. This makes it incredibly challenging to determine why the model makes the exact predictions that it does. What you can see is that when you use large language model predictions to autocomplete a prompt, the words that it generates are uncannily fluent, fascinating, and even useful. If you happen to be in the Bay Area, hello and welcome to the first live lecture of the course. So before we jump into things, there's just a couple logistics to handle here. The first one is that we have a new website. So if you check the link in the description, there's a new official course website. And again, this is something that anybody in the world is free to attend the lectures for if you want to. Second, we're going to be doing the discussion during this lecture through Discord. So if you want to answer questions, small little custom thing. And in general, super interesting and let you do a bunch of powerful things. So I say, let us just jump right into things. So as a first example, I'm just going to take this 8-bit Mario that we see, this very low resolution image, and I want to blur it. And if you're thinking about blurring an image, maybe the first thing that you could think to do would be to look at each pixel and kind of average it with all of its neighbors and do this sort of moving average. So the way I'm doing it here, we've got this little grid, 3x3 grid of values that's marching across the image and slowly creating a new image on the right. And to be concrete, what's going on here is each of those values is 1/9, and we're sort of thinking of lining them up with some pixels, multiplying each of those values by the corresponding pixel, and then adding them together. So in this case, if they're all 1/9, then we multiply them and we add them together. We're just taking an average of the 9 pixels. So in this specific window, it looks like there's 4 black pixels, 4 gray pixels and then one that's kind of the Mario skin tone color. So you would expect the average to be like a darker gray with the tiniest, hint of Mario skin color. And if we go and look at the new image that's being generated and what's painted into that pixel, it's that. It's a dark gray with the tiniest hint of some kind of skin color. And as we keep marching along, we get this blurrier image of Mario. We might zoom in on another example. Here, this grid, it's mostly covering the skin color with just a little bit of black here and there. So we would expect it to be a dyed down version of that, which is what we see. And this gives kind of a nice effect, right? We zoom out and we see what was once this nice, clean 8-bit Mario. Same resolution. Nothing's changed about the resolution, but what we've got is kind of this blurrier image. Now, a couple nuances about what's going on here, because as with so many things in computer science, there's edge cases to handle. In this case, it's a literal edge case, like what's going on at the edge. Because if we just let this grid of values fall off the side, and maybe we either don't count them or we're multiplying them by 0, what ends up happening is we would only be taking 4/9 of the given corner value, and it's going to end up disproportionately dark, which in some mathematical contexts, maybe that's what you want. You would want to treat the image as being something where outside of a certain domain, it's entirely 0. But when our eyes look at the blurred image, it doesn't quite seem right because you see all of this black or this sort of darker gray along the side. And what we expect is that this was an image taken in a broader context where what's surrounding Mario's world is the same gray that we would have thought. So in the problem set for today's, not today's lecture, for this week's lectures, you've got the task of basically defining a function that will handle this and a more general variety of what's going on here. And one thing to think about is what happens at that edge. And a typical convention in image processing contexts would be that when you're falling off the edge like that, you just multiply by the nearest value, right? So if you see that it's 1/9 times 0, instead of falling off the edge, you take the nearest value in the image. And that would make the boundary of our Mario look a lot more gray. So that's all well and good. But there's another nuance that we might want to handle here, which is, if we're not in a super low resolution context like this, but if we're in something that's higher resolution and we want to have a box that's a little bit bigger, like maybe I have this 5x5 box that's wandering along, it's a little bit strange to treat all of the pixels in that 5x5 box with equal weight, because the ones towards the center are somehow more representative of what's going on in that image at that point than the ones that are farther around. So for this example, what I've actually done, if we zoom in here, is I've given a grid of values that aren't all the same. It's not all 1 divided by 25 in this case, but the middle one is 0.162, and out at the farther regions, we've got 0.003. So when we multiply those by the corresponding pixel values, and then we add them all together, we're basically taking a weighted sum, weighted according to how close to the center it is. And that's a way of saying that, okay, it's okay for this pixel here to be influenced by what's at the outer corner, but only by a little bit. We shouldn't get into it too much. These specific values are coming from a Gaussian curve, also known as a bell curve. So you might imagine kind of this bell curve surface sitting on top of the image, and it's bulging right above the point that we want, and then it dissipates in values as you go away from that. And that gets us a much nicer notion of averaging the pixels, so that it's, like I said, it's taking into account how close they are to the point we want. The Gaussian specifically has some really nice mathematical properties that we might talk about a little later on in this lecture that makes it really, really quite nice for doing this kind of operation. Now, this operation that we're doing, as you can infer from the title of the video and everything about this and what we talked about last time, it's a convolution. What you would say is that the image on the right, the resulting values that we get, are a convolution of the original image with the little grid of values that we have here. Okay? So it's an operation that takes in, at least in an image processing context, two different grids of values. Maybe one is RGB, maybe one is numbers. They could both be numbers. And it combines them to get a new grid of values. In other mathematical contexts, we often think of it as combining two functions to get a new function. And when you're doing it with just this little smaller window, it's quite common to refer to it as a kernel. So in this case, we would say that we convolved Mario with a Gaussian kernel. Okay? And at this point, you might sit back and think, okay, that's all well and good. I guess with different kinds of averages, I could get different sorts of blurring effects going on in the images. And I guess there's some use cases for blurring images, like blurring out faces. But it goes way beyond that, actually. First of all, smoothing out an image with a Gaussian kernel is useful in a lot of contexts beyond what you would expect. But the important thing I want you to keep in mind here is not the specific example, but the general framework that's being developed, where if we tweak what the values inside that kernel are, we can start to do some more nuanced and interesting things with images. And to get to that, I say let's just dive right into actually coding up some examples here. So I'm just going to be creating a little Pluto notebook like I did last time here. And right now I've prepared it with an image. So I've created a large image is loading a certain image of Tom the cat. And then I've shrunk it down, mostly just so that it's easier to see on the screen, but also that makes some of the things faster to play with. So if we just check the size of the image, it's now a very small 500 by 399. And again, by the way, if any of you want to ask questions and you do so in the Discord, some of them will be like forwarded in my direction, and I'll try to keep my eye on if any of those have come in. So feel free to just do that whenever. And oh, I'm told my mic is peaking a little bit. So let me just turn that down a little bit, give you a better sound experience. Hopefully it's not too unpleasant in any ways. It's always so finicky to get these live streams to work properly. But we want to actually do this convolving operation, right? We want to actually see what happens when we mess around with different kernels. So first of all, to get a given kernel, there's this library that I'm going to use. We've got all of our definitions down here for various functions I'm going to have, but I'm going to be using one called image filtering. And in it, it has this module called kernel. And we can pull up the documentation for it, just using the live docs here, where it tells us the various different functions it has in there. And among them is this Gaussian, which is exactly what you want. But it already tells you that there's more interesting kernels that can be played with. And if I create a Gaussian, and I specify two different standard deviations, one in the x direction, one in the y direction, what it gives me is a grid of values. So we take a look, and this type is a 5 by 5 offset array. Okay, so essentially it's an array of floats, but the offset just means that the way that you index into it, let's give it a name like kernel, is such that the middle value is at 0, 0. So if I called kernel of 0, 0, I get that middle value that we actually saw in the animation, 0.162. And then if we take something like -2, which usually you can't index at 0, much less below 0 with Julia arrays. In this context, it's specifically offset. That doesn't matter too much. Just wanted to say it in case you were wondering what that term means. What we actually want is a nice way to take a look at what this kernel is. So I wrote a very simple function just called showColoredKernel that's basically pulling out the positive part and making it green. And then if a kernel has negative part, it's going to pull it out as red. So you can take a look at the details if you want.
यस सर, एकदम खत्म अभी होगा, फुल ऑन, एकदम काम शाम। अभी तो हम बहुत शेडी काम कर रहे हैं, रुको। कर दे दो, उसके बाद हम करेंगे फुल ऑन काम शाम। तेल का ऑमलेट एकदम भाई साहब, ये बेबी। ये लाइक वाइक कर दो थोड़ा, क्या कर रहे हो तुम? लाइक कर दो बंटा है।
Doubt that you're gonna need that, except you're gonna have thousands and thousands of connections. Scaling just this layer is enough to me to scale WebSocket connections. All right, guys, so That's it for me today. Hope you enjoyed this video. WebSockets, have a great weekend. I'm gonna see you in the next one. You guys stay awesome. Throw in all your questions that you have below. What should I make next? I am going to see you in the next one. You guys stay awesome. Hey guys, what's up? I want to make a new video talking about WebSockets, but I wanted to dive into an area that we haven't talked about in our previous videos about WebSockets, which is I'm going to reference below, detailing about the pros and cons of WebSockets and
Good morning, developers. If you are new to the channel, my name is Rob, and I want to give you everything you need to make your own chat app in Socket.io. And this is going to take about 60 minutes, give or take. We'll see where we end up by the time. It may be a little longer or a little shorter. And if you've done one of these before, a tutorial or looked around, you might be thinking, hey, Rob, it shouldn't take an hour to do that. You are right. We are going to do more than just make a chat app, which is to say my goal isn't really to teach you how to make a chat app with Socket.io. It's to teach you how to use Socket.io. I've been using it for about 15 years, going back to 2008 or 9, about that, when WebSockets were a new thing, when even Node.js was a new thing. And so this is awesome, right? We got a new cool thing to play with built into JavaScript, except it's not supported all the time, so I'm going to use Socket.io. We'll come back to that. Okay, so I start looking around online for some tutorials because there's not a lot out there, and I find, oh, here's a tutorial how to make a chat app. Kind of go through it, and I build something. Don't really know how it works because it was focused on code, but I made something cool. I look for another one, pretty much the same thing. I keep looking, chat app after chat app, and two sort of conclusions emerge. One, Socket.io is the chat app thing. When you need a chat app, you grab Socket.io, and until then, it just sits on your shelf. And two, nobody knows how this thing works because nobody was ever talking about it. It was pretty much just, here's the code to put your chat app together. Now, again, that was in the very beginning. Things are different now, but they're not that much different. It still is hard to find out how this thing works, and two, it's still kind of known as maybe the chat app thing, or at least a lot of developers lean that way. And I want to debunk both of those. It is a pitiful representation of what WebSockets or Socket.io, those will be interchangeable for a little while until we explain it. But that's a pitiful representation for what they are capable of. There is so much more probably in your applications right now that you could be doing with it that you maybe don't know until you have a sense for how they work and see maybe another example. And two, the under the hood stuff, yes, it is different, but it is not that complicated and it is not that different. So the way that the video is structured is, first of all, we're going to talk about this. This is the logical place to start. What is Socket.io? You may have used it before. You may have some notion. You may be confused. You may have never used it. You're just here because you want to make a chat app and you want to use Socket.io. Whatever the case, we need to make sure that we're on the same page. And as part of that, I'm going to go into contrasting. So we'll draw out the whole process. I'm going to contrast it with HTTP. Because if you are a web person, you are familiar with HTTP. Whether you know it or not, you use Axios or Fetch or Ajax or something like that to make HTTP requests back and forth to a server or something like that. WebSockets are not like that, right? Socket.io uses TCP and it is different. And I want to kind of make sure up front you understand what the process is like. From that, we'll kind of come back to the question, what is Socket.io? And we need to answer these questions. What are WebSockets? And we're going to need to look at the underlying networking protocol, which is TCP. This is sort of the no coding section of it. And I'll go ahead and put that around here. No code. And we're also going to have the drawing in there too, so that'll be part of this. But you may be the type of person who says, Rob, I don't do no code stuff. I don't want to hear your concepts. Just show me the lines of JavaScript and Node.js. Let's get into it. Please, if you're that person, please consider watching this. At least give it a try. Because if you go straight to code, you end up in that same place that I was at for years where I didn't really understand how it worked and I didn't understand any of the other applications. Okay, so this is the non-coding, and it is very important in my opinion. You can get a chat app tutorial in a zillion places and it will do a good job. So a lot of the value is going to come here. Then we will make our chat app. And this part, we're going to do in JavaScript and Node. There are other implementations of Socket.io, but we're going to do it in Node. This will get us to the point where we can set up the server, you know a couple of the different options, and we can work on, it's going to be simple. The UX is not going to be flashy. You can make it flashy if you want to, but it will make you familiar with emit and on. Those are going to be the two really big methods that you'll need to know. And then, as I said, a lot of the setup that goes into it, things like just getting the socket server up and running. Okay. And then after that, I am going to show you another project. We are not going to build it because there's a whole bunch of other cool stuff that Socket.io has that we can't do in less than like 15 hours if we actually code it out. So I'm going to take you through another project that I have, and it will give you a chance to see some of the work. You can pull down the repo and you can go through it line at a time, and you can make modifications if you would like to. Okay. So that is the plan for the video. Let's start off with what is Socket.io. I'm going to pull up the documentation here. This is the Socket.io homepage. So these are the docs. It claims about itself. It is bidirectional and low latency communication for every platform. Okay. So let's break that down. Bidirectional, low latency. I'm just going to do LAT, and then every platform. Okay. So those are our three points here. Bidirectional. Okay. This is going to come in where we're going to draw a little bit. So let me switch colors. Typically, when you set up our every platform. Okay, so those okay? It is bidirectional and low latency communication for every platform. Okay, so let's break that down. Bidirectional, low latency. I'm just going to do LAT, and then every platform. Okay, so those are our three points here. Bidirectional. Okay, this is going to come in where we're going to draw a little bit. So let me switch colors. Typically, when you set up a website, you're running JavaScript on the front end. That's not typically, that's what you are running. There aren't any other options unless you have WebAssembly or something like that. Okay, so we've got JavaScript over here, and I'll put that in there. Here's our JavaScript on our client. And then over here, we have ourselves a server. And it doesn't make any difference what kind of server it is. It could be Node, it could be PHP, it could be Python, it could be Java, C#, etc. Okay, they do not know, what the other is. This just knows it's getting HTTP requests. This just knows somebody on the other end is going to respond to an HTTP request. Okay, when we need data, we make a request. And again, that is using HTTP. Now, you may not know what goes on under the hood. An HTTP request has a header and it has a body. And in the header are things that you're familiar with, maybe MIME types, size, the date it was issued, all of that stuff. And then the body is going to be, on the request, is going to be usually pretty much empty. But the request goes out and the client waits. The server does, it's going to be listening at, let's say, port 3000. Okay, it doesn't matter what port. And it does its thing, right? Node.js or Java or whatever. It does something with that request, and then it responds, and then the connection is terminated. Okay? HTTP is stateless, meaning it does not maintain a memory or a log or a history or state of that connection. It's just request, response, we're done. If you want to make another request, you can, but we're starting from scratch. I won't remember anything about you. You're going to have to tell me who you are and what you want every single time. That's how HTTP works. The connection is made, and then once it's fulfilled, the connection is severed, and you have to start completely over. Okay? What we are using, what Socket.io uses under the hood WebSockets. And you may or may not be familiar with WebSockets, but this is a native JavaScript API. This is built into JavaScript. And as I said, back when I started, like in 2009, WebSockets were brand new and support was not consistent across the browsers. You had no idea whether it was going to work or not. So there were a couple different ways of managing it back then. Now pretty much everything uses WebSockets. So Socket.io is sort of a layer on top of WebSockets. And the way that it works instead here is I'm going to draw us another client. Okay, and our client is still running JavaScript. Okay, we've got the JavaScript part, the browser part that is going to implement WebSockets. We are going to use Socket.io to do the WebSocket part. It opens up a connection just like up here. The difference is it is going to use TCP to do so, and that connection is going to remain open. What is the advantage here? Well, if either side has something to say, you just say it. And you can remember, it is a stateful connection because the connection remains open. You can maintain a relationship, an ID to that particular session. A lot of variables and whatnot can be shared across the connection because it remains open. Unlike HTTP, which again, you make the connection, you fulfill the request, and then you are done. Here, this stays open until it's explicitly closed. This one is maybe like maybe a conversation with a stranger that you just meet in a park or at a random place. You give them one sentence, you say hello, they say hey, hello back, and then you pass on. And then if you ever run into each other again, you're gonna have to start over because you didn't really meet them. Unlike HTTP, TCP is more like a phone call where you pick up the phone, you talk, and you can talk for 10 or 15 minutes. Even on this video, you remember the things I said 2 or 3 minutes ago. I need you to because the conversation sort of builds on itself, right? If I need to say something on the phone, I say it. If you need to say something, you say it. This is a big win because with HTTP, the server cannot push out to the client. It would not be safe for a lot of reasons. The server could just randomly pick a browser somewhere on the internet and send something to them. You have to have special software to manage HTTP requests. And that's a big drawback if we need to push something out, okay? Because in the case of like a chat app, you're gonna have clients all over the place. And this person maybe sends something up. With HTTP, we don't have a way to pass it out to everybody. Hey, there's a new chat message. We need to wait until they ask for it, and then we could send it out to them. If we are connected via TCP, so the message comes up, the same thing, all of these clients will have a direct connection that is open. As soon as that message comes through and hits the server, we can pass them all out on a real-time type basis. So this is kind of the difference here. Is HTTP is request response, and usually that's what you want when you're making a web app. But sometimes you need bidirectional, meaning you can go both ways. The server can send stuff out to whoever needs it. The low latency part, that is kind of like the real-time part. Low latency means there's almost no delay. It has a really small amount of time required to send stuff out. So low latency could refer, I guess, to the network. The overhead is low, but it also would mean it's essentially real time, so that everything can be passed out pretty much immediately. The every platform thing, I'll let you decide if that's true. You can go check out some of the other libraries if you want to use them. But this is the gist of how it works. And the applications, yes, a chat message, but what if this were a video game? What if you're playing a video game and so is everyone else, and everybody has stuff going on? They're going to push it to the server, right? This is where my character's at. This is what my character's doing. And then the server needs to send out to everybody. This is where everyone else's character is at and what they are doing. Or maybe you have a web app like a ticketing system where everybody's looking at different seats in an event, and this person grabs a particular seat and pays for it, you need to let everybody else know, hey, that seat's not available anymore, or the prices have gone up, or whatever it happens to be. The server needs to communicate in real time, low latency, and it needs to be able to push stuff out to the various clients. You can't do that with HTTP unless you use long polling, which is actually what Socket.io falls back on. We'll talk about that a little bit later. Let me clean this up quick. So let's pull up the document. Documentation here for WebSockets, because as I said, this Socket.io is built on top of WebSockets, so we need to unpack that here before we move on. So let's pull up the docs here. Got MDN open. It says the WebSocket API is an advanced technology. Okay, let's pause there for just a second. Feel good because you are using an advanced technology. I always think that that's kind of a fun thing. That makes it possible to open a two-way interactive communication session between the user's browser and a server. So you can send a message to the server and receive a response that are event-driven without having to pull the server, okay? So if we compare the two, it said two-way interactive communication. That's the bidirectional part. They don't really have they used to have a pretty clear comparison with low latency. They don't anymore. But WebSockets are use TCP. Okay, it's the same thing that we talked about with Socket.io. So they kind of are doing the same thing, right? Well, they're kind of doing the same thing because they are doing the same thing. As I said already, we are going to talk about Socket.io. This is a library, and the library is built on top of an existing API, right? The underlying technology is the WebSocket API, okay? And this is, I'm going to put here, the client portion. JavaScript, the browser, I'll put that here, browser, is what uses WebSockets. They are not a thing on the server, on any server. Node.js has a WebSocket node module, but the server doesn't know about the WebSocket API because WebSockets are a browser thing. It has network sockets, and it knows how to connect to browser WebSockets, but no server knows about WebSockets. It doesn't care. It's Node.js, or it's Python, or it's Java, or whatever. The WebSocket API is a JavaScript thing. It's a browser thing. So the client portion of Socket.io uses WebSockets pretty much all the time. As I said, back in the early days, like 2009, 10, whatever, you had coverage on like maybe 40% of browsers. So if you were going to implement WebSockets, have a chat app like this, there was a good chance it wasn't going to work on the browser that was running it. So Socket.io did something called long polling. This was one reason why you needed to use it. In fact, I would say it was the main reason in the old days. What long polling is, so if you remember with our HTTP example, we have our client machine and we have our server. And if we can't connect via TCP, you have to send a request over. And so the way that long polling works is you send the request until one side has something to say. If this side has something to say, it sends a new request. Otherwise, the server just waits, and if and when it has something to say, then it will send a response. This will terminate, and you will immediately open up a new request. So long polling is essentially just, there's always a request, an HTTP request open, so that if the server needs to send something back, it can. Now this worked, but it was a terrible model because there was so much overhead. You always had this HTTP connection open. They timed out after 2 minutes or whatever the network allowed. This was not a great model, but it was something that we needed in the old days because WebSockets didn't have good support. They do now, but still sometimes we do need long polling because a proxy is misconfigured or a firewall simply won't allow TCP connection or something like that. So Socket.io uses WebSockets, but it also adds in long polling. In addition to that, it also adds multiplayer multiplexing, and this gives us the ability to use rooms, although that's not maybe the fairest example. Namespaces are the easier example, or the true example, but rooms are a little bit easier to understand. When you create the connection, so we'll switch back over here to TCP. So we've got our client here. It's going to connect to the server via a WebSocket. You might need more than one connection to the same server. So we'll have, it'll be like that, where maybe one is connecting to /admin and the other is connecting to /general, right? You have two completely different namespaces, different sockets or different WebSockets that you want to communicate with. Socket.io has that ability, and it uses multiplexing, which means you can use the same connection to manage more than one sort of room, right? Like admin and general. Again, it's namespace. It's just, it's semantics. If you're new, if you know how it works, then you know how it works. With WebSockets, you'd have to have two separate connections, at least as of the making of this video. You can think about this like a phone line. If you've got a telephone pole outside and the phone lines that run from place to place, you don't need 1,000 phone lines for 1,000 individual phone calls. That one phone line can manage 1,000 different phone calls at the same time. That's what multiplexing is, and Socket.io gives the ability to manage multiple namespaces or rooms, so to speak. It also has a reconnection feature that, as of the making of this video, WebSockets doesn't have. Now, maybe it will when you watch this, but it's very possible, and it goes a little bit farther. I'll put in here, though. It has a heartbeat. Both sides of this connection will keep track to make sure, is the other side still there? Because with WebSockets, it's possible to get disconnected, and the other side has no idea. So it's still sending events and listening for events, but there is no more connection. Socket.io has a heartbeat to make sure that both machines are connected, and if they're disconnected, it will reconnect. Another benefit of that is packet buffering, which is a fancy way of saying if there is a disconnection, then whichever side is trying to send data, it will hold that data in a queue and will send it in the correct order when the reconnection is established. There are a few other things doesn't have now, maybe multiple namespaces or rooms, so to speak. It also has a reconnection feature that, as of the making of this video, WebSockets doesn't have. Now, maybe it will when you watch this, but it's very possible, and it goes a little bit farther. I'll put in here, though. It has a heartbeat. Both sides of this connection will keep track to make sure, is the other side still there? Because with WebSockets, it's possible to get disconnected, and the other side has no idea. So it's still sending events and listening for events, but there is no more connection. Socket.io has a heartbeat to make sure that both machines are connected, and if they're disconnected, it will reconnect. Another benefit of that is packet buffering, which is a fancy way of saying if there is a disconnection, then whichever side is trying to send data, it will hold that data in a queue and will send it in the correct order when the reconnection is established. There are a few other things, but I want to keep moving here. The point is, Socket.io uses WebSockets. You could use WebSockets by itself and get this connection, get the TCP, get the low latency, get the bidirectional, etc. But all of this other stuff is what makes Socket.io so valuable. You're going to end up probably having to make this stuff. Maybe you have a fallback, maybe you need rooms, maybe you need a reconnect feature with a heartbeat, maybe you need packet buffering. And you will have just made Socket.io yourself, and that is silly. There are some phenomenal developers that are working on this that are probably better than you, or at least there's lots of them if you're awesome. It is also battle tested across the past 15 years or whatever. So Socket.io, in my opinion, in 2024, whatever year you're watching this, still makes sense. Instead of WebSockets, you're using WebSockets, you're just using WebSockets Plus. That's kind of how I refer to Socket.io. Let me clean this up again real quick. I have a video that goes over the reasons why you use Socket.io over WebSockets. It goes into more detail. I will link that in the description if you want to check it out. The TCP thing, I love talking about network packets and how things work under the hood from a developer's perspective because it's something that so few developers are ever exposed to. I have several videos that kind of go into more detail. I will link those. Please check them out if it's interesting. What I will say about where we're at is this. When you send a packet across the wire, right across the cables, there are two different models. I'm using the 5-layer model, but at the very top is the application layer. Right underneath that is the transport layer. I'll go ahead and finish them off. We have the network layer, we have the link layer, and then at the bottom we have the physical layer. Not going to go into detail right now, but what matters here is network is going to be internet protocol. Right above it, transport is TCP and UDP. These two things together, TCP/IP, create the internet suite, which you probably have heard of before, TCP/IP. The application layer is going to be things like HTTP, which we already talked about, FTP, SMTP, and so on, right? Various protocols that handle things at an application level. Application, HTTP, is built on top of the transport layer. So when you make an HTTP request, you're using TCP to get to the other machine. Once that's been established and the HTTP response is fulfilled, you drop the connection. In the case of WebSockets, we don't necessarily have to use HTTP. We can stop with TCP, but you can also make the connection by piggybacking on an HTTP connection, which is what I typically will do. I'll make an Express server and we'll use WebSockets or Socket.io to listen on that same port, and then the server can sort of sort things out. But again, we are going to be working at this level rather than at this level when we do Socket.io. And the important things to keep in mind before we start coding: one, there are two pieces, right? This JavaScript on one side, there is a server on the other side. You probably already have that down, but just make sure you keep it clear. And two, this is event driven. So instead of the browser initiating, the server responding, the line is open and either side can talk anytime. It can get really confusing because you don't know when the other side is going to say something. If you've got a whole bunch of different clients connected, you have to keep that in mind. It's a very different model, but it is so fun and so much power behind it. Okay, let's hop over to our code editor. Let's start coding and see how this works. We are on to the coding part. This may be what you were waiting for, but it is broken up into a couple different sections. The first thing we're going to do is I'm going to just walk you through my setup here, the files and how I do things to make sure we're on the same page. And then we are going to make a Socket.io server together. We will just code it out. And you'll just have to watch me. I will explain as we go. I don't like doing that. I prefer showing you the docs, but we got to start somewhere. Once we get to the point where we are connected and we've done a couple of the basics, we'll go over to the documentation and we will look back at what we did. And if you don't normally look at the documentations, I get it. I know it can be a grind and it can be boring and you just want to code, but the goal here is for you to be able to use Socket.io in your own projects and in your own stuff. And the only way you're going to be able to do that is to know where to look and to know how to read the manual. So that is a very important part of the video. And once we get finished with that, we'll come back over here to our code editor and we will finish making it look and work like a chat app. And then I'm going to take you through at the very end a project that I've already finished. I will give you the code, a link to the code where you can follow through with me. It is an online game. I want to be able to show you more of what the API can do, more possible use cases for Socket.io. And I can't make you an expert in an hour or an hour and a half, so that's a way to kind of bridge the gap. So again, we'll go over the setup. We will code out a server. We'll go over to the docs and look and see what did we actually do. And then we'll finish up the app, and then we will look at another project, the online game. So I've got Visual Studio Code. Any code editor you want to use is just fine, but I've got a folder called Socket.io Explain. Call yours whatever you want. Inside of it, I have server.js. This is going to be our node server or our Socket.io server. I have a folder called public, and inside of public, I have index.html, and this has just the Visual Studio Code boilerplate. You don't need to put this if you don't want to. The easiest way to get it is to just do an exclamation point and hit tab, and it will drop it if you use Visual Studio Code. But I have linked styles.css and scripts.js. So those are our two files. Scripts.js is totally empty. Styles.css has just a few styles in it to make the chat app look a little more tolerable once we get there. So you can grab this out of the repo. The link will be in the description. You can write your own, whatever is just fine. Okay? So we are going to start on our server, and to do that, we're going to hop over here to the terminal. I'm also on my Windows machine, which means I'm using PowerShell for my terminal. That should be the same on Linux, on Mac. The only reason you might have a slightly different command would be if you are on an old Windows machine and you're using the old command prompt or terminal. If that's where you are on your own, and I strongly suggest that you upgrade to PowerShell because it is very much worth it, very, very much more powerful. The first thing we're going to do, make sure you're in your root folder here. We're going to do npm init-y, and that will get us a package.json file here to work with. So here we go. We need to add a couple dependencies, and we will do that with npm, not sure what that was, npm install socket.io, and let me get that onto one line. There we go. So socket.io, this is the whole thing. It will come with the server and the client files. If you're in a situation down the road where you just need the client files, there is socket.io-client. We are also going to need Express, so please npm install Express. You'll see why here in a minute. And when you are all set, please run, I'm going to do nodemon on server.js. If you don't use nodemon, check it out. It will automatically restart the server every time we make a change. Right now, our server is doing absolutely nothing, so let's hop over and fix that. So we will start off by bringing in Express, and we will require Express. That is the module we just installed, and we will do const app. We will invoke Express, and I'll put a comment here, make an Express app. The reason that we are getting Express, we'll do app.use open close. We're going to do express.static, and we're going to hand that public. We need a way to serve up the index.html, the scripts.js, and the styles.css, and that is going to be Express's job. That's what this will do here. And we will drop in here app.listen. I'm going to do port 4000. Pick any port you want. It is totally arbitrary. I'm just in a 4000 mood, I guess. And I'll drop a comment in here on line 3. Serve the files in public statically. Okay, this gets us into a position where we can at least hop over to index.html, make sure that you are all caught up here. I'm going to drop it in H1 and say Express server is working. This is just a basic sanity check. We want to make sure back over here we don't have any errors, and you can see nodemon is restarting every time I save. We want to make sure we don't have any errors, and we want to make sure we see this this H1. And here we are, localhost 4000, Express server is working. So make sure you can get at least here so you are ready to move forward. We are going to now come over here and we're going to do const socket.io equals require socket.io. So that's the other module that we installed. It's right here in this variable. We are going to make a variable called IO, and this is going to represent, I'll go ahead and put that here. IO is our socket.io server. The reason I call it IO is because that's what they do in the documentation, or at least they used to, and it's just habit. You can, of course, call it anything you want. But I'm going to grab socket.io, I'm going to do open close, and we are going to hand it, well, we need to hand it our HTTP server, and that's line 5. We can't hand it app because that's going to be a callback or a function. So we're going to do const, let's call it express server equals, and we're going to get the return value of app.listen. That will be the actual HTTP server. So on line 9, we're going to hand our express server over, and then we're going to hand just an empty object here, which will be our options eventually. Alrighty, that right there will get us a socket.io server. So we're going to go over to index.html now. You can hop over to your terminal, make sure you're not getting any errors. That is no fun to code a whole bunch and have a bunch of errors in your wake. Make sure you've got scripts.js loading up. Right above it, we are going to drop in another line. We're going to put in /socket.io/socket.io.min.js. This file is being served up. If we come back over to our server, it is being served up right here. This thing is going to make it. We'll come back to that. But this will put the IO object in our client. So just as a test, I'm going to log line 1, our IO. Come back over to our browser and refresh. And on line 1 here of scripts, this is the IO object. I'm going to make sure it looks something like this, maybe not exactly, but we have two parts. We have the server, this is the socket.io part, talked about that at the very end of the whiteboard session, and then we have the client. So these are the client files, that's what's gonna run on the browser. This is our node server that's gonna handle the socket.io traffic. This is sort of that center for all of the individual clients. We have the IO object, come back over to index.html, because this is putting it in the global scope. It's adding it to the window object, okay? When you are ready, come over to scripts, we don't need this line anymore, and we will do const socket equals IO. We're gonna hand it http://localhost and then whatever your URL happens to be of your Express server. Because the IO or the socket server is piggybacking on the Express server. So this right here, if all went well, you shouldn't have any errors over here. And if we come back over to the browser and refresh, you don't have any errors down here. If that's the case, even though you can't see anything yet, that means something good happened. And what we'll do is come back over to server here, and let's drop in our very first thing. We'll do io.on. And make a note here. On is a regular JavaScript/node event listener. We'll see that in the documentation, but IO is our socket server. So anytime you see IO, or whatever you called it, we're referring to the whole socket server. We're going to listen for an event. What event? We're going to listen for the connect event. If that happens, the second thing that we hand it will be a callback, and we call the thing that we get socket. So this callback is going to run. If you prefer, it can look like this. If you're still kind of pre-ES6, it could be this as well. Any of those, they're all going to be the same because we're not going to use this. I prefer to keep it nice and short like this. We get socket when it connects. Connects to what? Our IO server. In here, let's do console.log, socket.id. Let's go a little bit further. Let's do socket.id, comma, has joined our server. So if someone connects, right? What connects? A socket connects to what? Our IO server, right? On connect. This code line 15 will run. Why would that happen? Well, over in our JavaScript file, we are using the IO object, and I'll make a note here. IO open close connects to the socket IO server at the URL. This is going to make our connection. The reason we have the IO is because in index, we brought it in right there. The reason this is here is because when we started up our server, it started running. The moment of truth, if we hop over to our server, all right, the terminal should hopefully show this in here, that you've got whatever socket ID has joined our server. I misspelled joined. Sorry if that is bothering you. It was not on purpose. We have made a connection, and this is going to be pretty much the same in every socket IO app that you have. And you don't have to use Express. We'll come back to that. But we're using Express to serve up our files. We've made our socket IO server, and we're listening for sockets to connect. Inside here, we can do one better. I'll make a note. Emit is the other big method, and I'm going to move that up top here. This one actually goes there, but I've got emit is the other big method. It comes second, I guess, in order. We can do socket.emit, open close, so this is a method. This is going to send an event. So on listens for events, emit sends events out. Who are we going to send it to? We're going to send it specifically to the socket that just connected. Okay? In that first argument, I'll make a note here. First arg of emit is the event name. This can be pretty much anything that you want it to be. The second thing is going to be the data that we want to send over. I'm going to send over an array with the numbers 1, 2, and 3 in there. So this callback, I guess this callback is going to run on this event. We're going to get this log, and then we are going to emit to the other side. So we go over to scripts. We've got our socket. So our socket has an on method and an emit method. Those are the two big ones. Let's drop them down a line here. It has an on method and an emit method, just like on the server. So let's put that in there, just like on our server. Our socket has, there we go. We can put in here socket.on, listen for the welcome event, just like on the other side. The first argument is the name of the event. What are we listening for? The welcome event. So on welcome, we're gonna run a callback, so I'll have data, and we will just console.log data. If all goes well, we'll have to refresh because this is a new thing on our browser. Data will come through as an array of 1, 2, and 3. And if we come back over here, every time I save, the server's restarting. Let's go see if we got line 9. Quick refresh, and there we go. It is coming through. So what we've done is we did our initial connection, our handshake. This initiates the connection. This is listening for it. And then we are sending via TCP. So this is real time. We are pushing an event. Push an event to the browser or the client, whatever, I guess client is more generic. Socket.emit does just that. Now over in scripts, we're listening for that event. We can do the same thing. We can, inside of welcome, once welcome is emitted from the server, we run this callback. Let's put in here a socket.emit. So we're going to send an event back to the server. We'll call this the thank you event. And we'll send back over, let's do 4, 5, and 6. This is going to do the exact same thing, but from the client side. So this is just like a phone call. This is listening to the other side, and this is saying something. Both sides can do it anytime they want to. Come back over to the server. We're going to put this inside of our connect. You can save things differently, but typically you're going to add your listeners inside of the connect method because that's where you have access to this particular socket. We will come back to that in the documentation, but socket.on, we're going to listen for the thank you event. We're going to get data just like we did on the other side, and we will console.log it, message from client, comma, and we'll throw the data at the end. So if all goes well, we will see 4, 5, and 6 on this side. Come back over here. Let's refresh. Back over to the server. There we go. I refreshed a couple times by accident, it looks like. But everything's happening so fast, we can't really trace it. But we're getting our connection. This is happening inside that listener. We're getting our message from our client. Why? Well, as soon as they connect, we send welcome out. Back over in scripts. Meanwhile, before I guess we go over, we're going to listen for thank you. Whenever it happens, it happens. If it doesn't, it doesn't. Over in scripts, welcome will have just happened. This callback runs. We log the data, and we send back over the thank you event, which has 4, 5, and 6. So I hope you're seeing what's going on here. We can push, and we can listen from both sides anytime we want to. The server, meanwhile, has gotten this event. So let's hop over to the documentation and try and make some sense out of everything we just did. And I really encourage you to watch this because this will be very, very helpful. If you hover over top of the docs and click on guide, all of the stuff over here, there's a whole bunch of different topics. It is really, really useful. Now, it's not casual reading. You won't just want to read through everything, but over time, this will be a good place to come. I think I read all of it, and it is almost all worthwhile. In the introduction here, we already talked a little bit about what Socket.io is. We scroll down a little bit. The server implementations, remember the any platform, it's not any, but Node.js, that's what we're using. We have another implementation, and then Java, Python, there's actually 2 Javas, Golang, and Rust. And these 2 are managed by Socket.io. These are managed by individuals, by community members. So just be aware of that, but they should work if you want to use it in another language. The client implementations, and this might look a little bit strange, but the browser here, that's what we're using. We're using the client implementation, which is coming with our server, but you can make a Java client. So you have a Java server running that would be acting as a client connecting to a server. So a whole bunch of Java clients or C++ clients, etc. So just something to be aware of. What Socket.io is not, it is not a WebSocket implementation. So just make note of that here. If we hop back over to our client, this line will not be able to connect to a WebSocket server on the other side. And if we go over to server, this will not allow a WebSocket connection from the other side. You will see a little bit later, you can use WebSocket protocol, but you can't make a new WebSocket and connect because it's not a WebSocket implementation. They just got some notes here. For that, you would use WebSocket, which Socket.io uses under the hood. We'll see that in a little bit. Okay, keep going down. Under features, this is all stuff we talked about on the board. You can kind of look at this a little bit closer if you would like to. Gonna click on how it works. A few things here. Socket.io is broken up into 2 specific layers. The first one is Engine.io, and Engine.io handles the low-level connection between the server and the client. It says here the low-level plumbing. That means that it handles the transports, and if I click on that, there are 2 transports that come out of the box. There's HTTP long polling. That is
That's the part where we send an HTTP request, keep it open until the server responds, or we need to send something. WebSockets is where you're almost always going to want to go to. That's kind of the point of this whole thing. But Engine.io manages those 2 things, as well as the upgrade mechanism. Out of the box, it's going to use HTTP polling, long polling. It does take a little bit of time to establish the WebSocket, and so this is kind of a nicety in between to give the user a good experience if there's a delay in the WebSocket connection. So that's thing 1 for Engine.io. Thing 2 is the disconnection detection, which we talked about. There's the heartbeat, and then all of this stuff, just trying to determine has one side lost the connection, and if so, that's Engine.io's job. You're probably not going to interact with this until you get really advanced. I very seldom make changes to Engine.io. There are some things in the API, which we'll see in a minute, but for the most part, what we interact with, so that was part 1, mostly what we interact with is the high-level API, which is Socket.io, and we will be over there in just a second, okay? So you can look at all this stuff if you would like to, a little more detail about what Socket.io does, but it's just the features we saw on the last page. With that, I'm going to hop over to the server API, which is this page, and they've got a nice diagram here, which you can check it out. They've got the Engine.io, which we just talked about, but let's look at a diagram here. Here, which you can check it out. They've got the Engine.io, which we just talked about. But let's look at how our code actually worked. The very top here, the constructor, and over here, the server, capital S server. The constructor is how you make a Socket.io server. And there are 3 different ways to do that. We did the first one where we did new server and we handed it an HTTP server. So back over to our code. We made an Express server right here, line 5. This is an HTTP server. That's what Express handles, HTTP traffic. Line 9 here, we called Socket.io and we handed it our HTTP server. That is what we've got here. You can second argument pass it some options, and we'll look at those in a second. We scroll down a little bit. Another way you can do it is you can simply hand it a port. If you don't need HTTP, and in our case we do because we need to serve up our static files, but if you don't need it, you can simply hand it a port. And you can use, there's a server object that comes directly out of the Socket.io library. You can grab that. The last way down here, if you don't even have a port, like out of the box for some reason, you just want to get the server going and add it later, you can just give it options. And then down below, you can see there's an io.listen, whereas up here, you don't have the io.listen, you gave it the port when you started it. Okay, so those are the 3 different ways. What we did was this first way, where we handed it our server and we handed it our options. What are the options? Well, right here, this line will take you to this page. And there's a lot more here than we're going to be able to cover. I just want to make you aware of a couple of things. The adapter. This is a bigger concept than you probably need to worry about right now. You almost certainly will not use a different adapter than what comes out of the box. The in-memory adapter is the default value, which is socket.io-adapter. If you click on adapter, it will bring you to this page. And the adapter is a server-side component which is responsible for storing relationships between the socket instances and the rooms. We haven't talked about rooms yet, but you can think about it like you maybe have, back over to our code, if over in scripts here, we make one connection with the socket, we might on the server want to add that socket to 2 different rooms. Maybe the game room, and that will be broadcasting all the messages about the game. Here's where all the players are. Here's what they're doing. Here's their inventories, that kind of thing. And maybe there's a chat room, and that's where you're broadcasting all the different messages to different players. The adapter is in charge of managing that stuff, and it's also in charge of broadcasting events to all or a subset of clients. So again, if you happen to have a socket or maybe 50 sockets in the game room and you've got 1,000 connected to the server, you only want to send out to 50. That is the adapter's job. And again, the in-memory adapter is what you'll be using out of the box. As you get more sophisticated, you might want to use Redis instead of in-memory because Redis might perform better. If you get to the point where you're going to use the cluster module, you'll want to use the cluster adapter. The Redis adapter will work with it, I think, eventually through some of the upgrades. That's been a little bit bumpy lately, but you get the idea. The whole thought here is that the adapter manages how you broadcast to different clients, and here are your options if you want to use MongoDB or Postgres to manage that, or Redis, etc. Okay, so that's the adapter. We keep scrolling down here. The path, the default value here is /socket.io. This is the name of the path that's captured on the server side. So if you want to access something over there, back over to index, the reason that this is socket.io is because the default path is socket.io. If you wanted to change it to something else, you could. Scroll a little bit farther down and we have serve client. This defaults to true. If it's true, then it gets served up. Well, we've already talked about that. Socket.io.js, min.js, and then the package here, they get served up if this is true, and by default it is. If you come back over to your server and we drop in our object here, I'll put in false. So it will stop serving that up, back over to our server and refresh, we get a 404 because it's not being served up, and then we get an IO error because it was never added. So I'm going to get rid of that. Back over to our options. Some of the engine options to take a look at. Most of these you'll know if you need them, but the cores one is going to be the most common one that you probably will need to add so that you have access, or so that you can limit access. The default value here is dash, which means nothing will be allowed. Now we are okay because our server is running on localhost 4000, and so are the files. So we don't have a cores issue. But if you were running, say, a React app on a different port or a different URL connecting to an API, you would need to add this in. So as a quick, for instance, here we'll do cores, open, close. It is an array, and I'll put in here right now localhost 4000. Hopefully you know how cores works, just to handle cross-origin requests, but this is an important one to be aware of. Going a little bit farther down here, let's actually over here on the right-hand side, I'm going to click on, let's start with ping interval. This is set to 25 seconds by default. This is the heartbeat mechanism, which will check if the connection is still alive between the server and the client. It's going to be a little bit a matter of taste, how low or high you want this, but this is out of the box what it is. The ping timeout is how often it will try and reconnect, which by default is 20 seconds. The transports, the default value is going to be polling, so start with polling and then upgrade to WebSockets. If you switch the order, it will try and do WebSockets before it does polling. I would say this is probably important to keep unless you have reason to change it. The last one we'll talk about is the WS engine. Out of the box, this will use the WS module. And if I hop over to NPM here, the WS module, one thing I love about it is it has zero dependencies. 17,500 different modules do depend on it though, one of which is Socket.io. And you can see here 65 million weekly downloads. So this is a crazy important node module for the internet. I don't know why you'd need to use something else. If you're in a situation where you do, this would be how you would do it, is with this option. Okay? So that is the constructor. There are 3 ways to make a new Socket.io server, sort of. As I'm sure you noticed, we didn't use any of them. New server is not in our code. Line 7, we require Socket.io, and we store whatever it exports in Socket.io. And then line 9, we just invoke Socket.io. So we should have this based on what the documentation is saying, but we got away with this. Why is that? Well, just a quick side note. If I open up node modules and I go down to Socket.io here and open it up, go to dist and index.js. This is what we are requiring when we require Socket.io. I have scrolled all the way down to the bottom of the file here. Line 785, exports.server equals server. Well, coming over here, the reason that you can import server, they're destructuring it from the Socket.io module, is because of line 785. Scroll down a little further here though, the default export, meaning if you don't ask for a particular object, it's going to be this callback. This callback that expects a server, expects options, and is going to return a new server with server and options passed to it. They are doing this work for us. I don't know if I am a relic and I'm just doing things the way they've always been done and I'm supposed to update and the documentation is trying to say that, or the documentation has updated itself, but this still works, or rather, I guess this still works because they are still on line 797 here doing a module.exports and they're sending it out. So we can do this. I'm going to leave line 7. I'm going to do const server equals require Socket.io. So this is how they are doing it. The way the docs make a server. Actually, let's say the object the docs use to make a server. And then down here, instead of line 10, I'm gonna copy this and comment it out, and I'll paste right below it. Const.io equals, instead of Socket.io, it'll be new server, just like that. Everything is exactly the same. I just swapped out the default export with new server. If we come back over and refresh, everything works as it should. So this is just maybe a little tutorial on how node modules work, but that's why this works. And I want to make another note while we are here. We've got IO is our Socket.io server. I'm going to make another note here. Capital S is the server constructor in the docs. It's the top thing. Small s is the variable in the docs for the server. We call it IO. Let me show you what I mean because this is easy to get hung up on. Capital S server up top here, that is the constructor. That is what we are using to make lowercase s server. All of these lowercase s's over here are the actual variable names. So if we go to server.on, which is right here, they've got server.on. That is, again, the lowercase s is the server we have made from the constructor. Down here, they have actually called their server IO just like we have. So server here is a generic name for, hey, this is a Socket.io server that came from capital S server, the constructor, but the variable name is IO in their example code. The same thing's true over here. We have now grabbed the capital S server. We made a new server, lowercase s, but we called it IO. And we've got that line here. The small s is the variable in the docs for the server, but we call it IO. So to illustrate this a little bit, we've already got a little bit of code down here to help out. We have an IO.on connect, okay?
प्रसाद खिलाता है, या जो बहुत दिमागी कार्यों में लगे हुए हैं, जैसे
Connect. Connect to what? I/O. What is I/O? It is the server. That means the entire server is listening for a new socket to connect. Down here we have a socket.on thank you. Okay, if the thank you event happens, on what? On the socket. So this belongs not to the whole server, but to an individual socket. These are two different listeners on a connect event to the server, on a thank you event to a particular socket. Right here we have emit on a socket. That means emit to this particular socket. So socket.emit will emit to this one socket. If we put right below it io.emit, we'll do hello all, and we'll send out with the string hi inside of it. This io.emit will emit to all sockets connected to the server. Again, the server lowercase s is our variable io. Hopefully that makes sense. We've got two different types of emits here. We got two different ons. Over in scripts, we only have one option because the socket is connected to the server. It doesn't know about any of the sockets, so it only has an
ও তুমি এসছো, দেখিনি আমি। গ্রিড বানাচ্ছি বসে বসে, গ্রিড। এলাকা একটা জিনিস দেখবে? জেলি। Meow meow. Yeah. Grid auto column. Follow. बच्चों ना चलाओ। Grid auto, grid auto. whatever you একটা ওরা তো হচ্ছে 11 square that's right. Okay. 51 64 কি করে দেওয়া উচিত গ্রিড যতই Let's go. 7 hours, baby. Almost 8 hours. ব্যাস জিটা আমার গ্লোবাল স্কোপে কেন হয় না? দীপেশ ভাই বেরোলাম তোমার digit okay. Nice. কি হলো ভাই? চলছে না? চললো না কি জানি। তো যাবো লোকাল হ্যালো ওয়ার্ল্ড। কি আছে? This is the distribution folder, nodes, module, source. Paste, I do not need paste. Next, CLI JSON. Okay. This is the log version. Package JSON. Start dev debug linked test. Watch debug. SWC. There's just node. These are the types. I do not need to think about those things. JSON. I do get the case config is here. Nice. App service. App controllers. Okay. Done. Controller specs, controllers, module, service, main content. Get hello world আসছে কোত্থেকে? slash, that's nothing is here, slash routed, run this service, okay, which is get understood. Providers any class that can be injected service. There was one more thing is this like okay. DTOs, data transfer object. Define the structure of the data in request response. Okay. Helps with the validation with using library with class validator. I've used the data validation and transformation example validation pipe to validate DTOs. There's body controller, post, use pipes, validation pipes for next count, DTOs. Are there DTOs? I don't see them. Oh, this is modules of control. No DTOs, okay. Setting up type 1. Middlewares, guard, authentication authorization, interceptors, filters, WebSockets. Thanks.
developers.
You're encountering challenges, you're trying to figure out how to solve them, you're failing, you're thinking about what mistakes you made, how you could do it better, you do it again, and you keep doing this over and over until you overcome your challenge. Like, that's growth mindset, right? Like, isn't that incredible? We're like, kids are experiencing this, just by playing games. Or you think about playing games with your friends and against other people. And what do you need to do? You have to learn how to cooperate. How do you divide up tasks? Who steps in a leadership role? How do you be a good follower? When do you trade those places? How do you learn how to be a good, not a sore loser and not a sore winner? Like, these things all happen when you play Fortnite. So like, games are such amazing little simulation sandboxes to get to interact with these things that are basically like microcosms of real life, and you can learn these skills in safe places. And my guess is there's something to do with being able to do those things over and over and over and over and over again in a way where you don't even realize you're learning those skills because you're just having fun, that may translate to the kind of things you need to do to run a company. I don't know. I mean, certainly I did.
You mentioned levels there. In games, you have levels. It gets harder, generally, the way that games work. If we align that parallel to company building, which level of company building was the hardest? And what was the cheat code that you used to break it?
Oh, wow.
Swahila's like, what the fuck? This wasn't in the schedule.
No, it's a great question. I mean, each level brings about different challenges, and I think one of the hard things about being a CEO and being a CEO, maybe also being a founder, is like, each time you get to that next level, like, you haven't done it before. So by definition, you're just like constantly figuring out, how do you work through these new challenging dynamics? And for different people, I'm sure different parts of it are easy and hard. But I don't know. It's just, it's always hard.
Was that one where you felt like I'm not equipped for this?
Well, frequently I would encounter situations, and it still happens, like almost on a daily basis, where I'm like, I've never done this before. I've never seen this before. But the one thing that I have confidence in myself and my team is that we can figure things out. And it comes back to that growth mindset. When I'm faced with a challenge that I don't know how to solve, I can usually figure it out if I work hard enough. So that's just kind of my mentality with everything, is like, we're just going to figure it out.
I think that mindset is helped when you're not existentially worrying about rent, actually. And I've thought a lot about how money influences an investor's mindset. I'm interested, you sold your prior company for $104 million, to be precise. I love the four, like 100 wasn't quite right. Yeah, well done for pushing that one. My question to you is, do richer founders make better founders? And how do you think about the financial cushion benefits?
It certainly helps in a sense that every successful company along its journey gets acquisition offers. And so by having a cushion, it made it easier to turn down offers, because we could just go for the big, outcome and try to build a generational company. So in that regard, it does make it easier, I think, to build a more impactful, more important company. But I think the real impact from being a second-time founder actually has to do with the levels, and how there are a lot of levels I had already played once in my previous company. So there were things about building my second startup, about building Discord, that were easier in the beginning because I had done them before.
What's harder the second time around? Fundraising is easier, hiring is easier. What's harder?
The second time around, what was hard, I don't know if it was harder, but what was hard was still cracking product market fit. Like, we had an insight around the shape of the business that I wanted to build and the types of products we would make, but getting the specifics right are just hard. Even when you know what you want to make, it's just hard. And so I don't know that it was harder, but it was hard, and I was able to focus more on it because I wasn't so overwhelmed by, like, how do you manage 25 people?
What was the first unique insight that you had with Discord? I always believe that when you go into an investment, you have to have a thesis which can be proved or disproved. When you go into founding Discord, what's the thesis?
Yeah, the thesis back in 2012, at the time, my sense was that the way you built a durable company in gaming over time was you actually needed to have some kind of established distribution advantage. And so I kind of put these things together and thought that, like, the shape of the company in the future would be a group chat app focused on gaming, that helped developers bring their content to life. And that's essentially what we're doing now, 12 years later.
Can I ask you, when you went out to speak to investors in the early days, What was the number one reason why they said no?
Well, in the very early days, we started the path that I sort of took us on had some twists and turns. And at the very beginning, what I thought we needed to do and the approach we took was actually we started by building a multiplayer game, a cooperative and competitive, like a team-based competitive game on mobile. And my thought was that we needed to build this game to kind of bootstrap the network of the group chat app. And so a lot of investors said no because they didn't think the game was going to be successful. And I suppose they were right. Like the game had a really nice following. I was very proud of it. It was called Fates Forever. But it was not going to be a venture scale business. Like content is tricky. It wasn't a hit and it didn't amass the kind of following that we needed to bootstrap a network. But by going through the process of building the game, we identified like a path to market with a group chat app that didn't need a game to bootstrap it. And then so we built Discord actually in 2015. So the journey, it's one of those funny things where we were like stubborn on the vision, but flexible in the details. And it all sort of worked out over time. And, you know, as we keep talking, that's kind of the theme of the story.
Did you have immediate product market fit when you launched the group chat app V1?
It was pretty fast. I wouldn't say immediate, but it was pretty fast. You know, we started working on it January 2015. And within, I'd say 2 months, some of our friends were very excited about it. But we didn't really have any users, but it was pretty clear they wanted to use it. It just like wasn't exactly correct. So we rebuilt the voice chat engine 3 times, you know, for example. But I'd say within 3 or 4 months, we had like 20 DAU that weren't us. So pretty quickly, but 20 small.
So do you agree with the principle of build it and they will come? No,
I do not. I think the Discord story was actually a perfect example of how build it and they will come may not always work. Now, sometimes maybe it works sometimes, but at least for us, it didn't. And, you know, when we got to this place where we had 20 DAU, we actually were having a hard time figuring when we got to this place where we had 20 DAU, we actually were having a hard time figuring out how to get more people to use the product. We were like, how do we get the word out? Because everyone was actually very skeptical about a group chat app for gaming. People would say this is the dumbest idea ever, like no one's going to use this. And even people who played games, many of them thought like, why would I want this? I already have, you know, whatever app I'm using. And so we were having a hard time getting other people to try it, but we ended up figuring out kind of a way to get the word out that people responded to positively that caused them to start trying it. And then it started to grow on its own. But there was like a period of 3 or 4 weeks where I remember we were sitting around thinking like, well, we like this, but maybe no one else does. Like we had built the product and we just hadn't figured out how to get the word out.
What was the unlock?
The unlock for us was inviting people to give feedback on the app. As opposed to saying like, try this thing out, like we're selling it to you. What we actually did is we went to the Final Fantasy XIV subreddit on Reddit, where there was a new expansion coming out for this game. And we got one of our friends to make a post on the subreddit, basically saying, hey, I'm trying out this new voice over IP app. What do y'all think about it? And then they basically said, I found this thing called Discord. What does anyone think about it? And we went into that thread on Reddit and posted a link to a Discord server, which is like the group chat. We call them servers, where me and my co-founder were hanging out. And people were like found it on Reddit, clicked on that link, went into the server, and then they were talking to us and trying it out. And they went back to the subreddit and were like, hey, this is pretty cool. I met the devs. They seem pretty cool. We got 50 users that day from that post. And then that 50 turned into 100 the next day. And it sort of started to snowball. And then we kind of did this playbook a little bit for like 6 months. And that was basically the beginning of how it started growing.
Did you ever have a plateauing of growth where it slowed?
Yeah, it's not all been up and to the right.
What do you do then, Jason? Like, do you go back to the drawing board and go, what features can we do to supercharge this?
Yeah, it's a combination of thinking about how do you continue to make the existing product more useful and better for the people who are using it today for what they're trying to do. And then you got to try to think about like, how do you make it, more approachable for people that aren't using it today? And these are some of the areas where we, during the COVID years kind of branched out in a way to try to help be more useful to so many people because of what was going on during COVID. And over a few years sort of following that, realized that we kind of went down some dead ends a little bit, and that people were not resonating as much with some of the features we were building. So we kind of pulled it back in to refocus on gaming this year.
Do you regret the expansion into more verticals to attract more people? And did you learn anything from that, like audience creep?
I do not regret it. It introduced Discord to a lot of people, and many of those people continue to use Discord today. So we, while we went in a bunch of different directions to try to be useful to all those folks that maybe didn't yield as much of a business impact that I was hoping, we certainly, our business grew tremendously during that period. And I learned a lot about how do you manage a company at the next level. We went from 200 to 1,000 employees in that time period, which was like totally crazy. The whole founder mode thing is interesting. I kind of went through my own experience of that, and now realizing, other people had similar experiences was kind of interesting. But yeah.
I have to touch on that. 200 to 1,000, the scaling there, incredible. PG obviously famed for many things, but obviously this blog post has been incredibly viral. How do you reflect and think about founder mode when you reflect on the journey with Discord and the 200 to 1,000?
Yeah, that period for us when we went from 200 to 1,000 in basically 2.5 years was the moment in time when I think I made the most management mistakes at Discord. And a lot of it is where basically I hired a lot of people, and because it was a new level that I hadn't really, dealt with before, and it was hyper scaling and all this craziness, I kind of followed the best practices, and I hired a bunch of executives and set the vision and delegated the work to them, and everything ground to a halt. We did a lot of things that didn't end up resonating with our customers. And I have, I think I kind of realized this maybe at this point now, maybe almost 2 years ago. It was like it took a couple of years, and then I realized it and went on this journey to try to fix it. But it was hard because I was essentially trying to undo all of the best practices that everyone thinks that you should be doing when you're running a company.
So what those being delegation, hiring execs who've seen it before. What else? Anything else?
I don't know that I have like a cataloged list in my head of things, but words today that trigger me, which I think are shadows of this, are words like empowerment, alignment. Like
my team have a drinking game where the more the person says alignment, the worse the CEO they are.
Yeah, I now say alignment is a 4-letter word. Like I don't want alignment. I want highly opinionated people making decisions and then being accountable for them, right? So this is like, some of this stuff that I think people get caught up in.
And so was there a realization moment for you? Oh shit, I've become manager mode. I need to go back to founder mode.
I mean, I didn't have those words for it. This was a couple of years ago, but the realization for me was like, we are not shipping great products anymore. It's not coherent. The stories we're telling don't make sense. I feel like it's hard to get things done. I feel like I'm fighting against the company, not with the people trying to achieve something. So it just like felt broken.
Just breaking them down. Delegation, something that's like told for years to gain scale, leverage. How do you approach delegation today? What do you delegate? What don't you?
Yeah, so delegation is still very important. And this is why this stuff is a little bit tricky, is it doesn't mean micromanage everything, don't delegate anything, don't give people space to be creative and make, like, it's not that you shouldn't do any of these things. It's that you need to be careful about how you do it. So for example, now I'll give you an example. So today I have a process where the way I manage the work is I essentially, when we do our sort of plan for the year, instead of me sort of giving a high level, vision of like, here's the kind of outcome I want to have next year, I will tell my teams, like, these are the problem spaces that I want you to focus on. These are the kinds of solutions I'm expecting to see. And then they come back to me and I literally pick all the projects now. Like, I'm literally like, okay, we're going to work on, improving reactions like that. And we're not going to work on well, I'm not going to say we're not going to work on it. I don't want to leak any features, but like, so I will literally go through and pick all of the projects now. Whereas like a couple years ago, my team was like, oh, we have to be empowered to pick the projects. Just tell us what metric you want to move. And I was like, okay, I guess that's how you run a company. But now, no, I'm like, I pick all the projects. I'm very tops down on what the strategy is and how we're allocating resources, how these things are sequencing together over time. So it's coherent to our users.
How do you think about creating an environment of ownership when one is told bluntly direction like that and they're not making choices?
I think that the mistake was pushing those decisions to the wrong elevation in the company. So like when I go to a team and I say, hey guys, like I want you to think about how reactions work and how we can make this better for people. And here's some specific ideas for how to make it better. What I'm actually saying to them is like, I now want you to use your incredible creativity and energy to try to explore this part of our sandbox. So they have extreme ownership over, okay, like these are 2 or 3 ideas that Jason has that he really wants us to do. They can tell me they think I'm crazy and then we'll argue about it. Maybe they're right. Sometimes I'm wrong. I mean, I'm not right all the time, but also there's a problem space there and they can explore and ideate and think within that problem space, but then they're going to pitch those ideas back to me and I'm going to pick the ones that they're going to do. So they still get to have ownership and accountability and creativity on like what the work is, but they're not, accountable necessarily for, should we even work on reactions now? Like that's somewhere else in the organization. That might be me, or that might be me with the VP or something. And the VP's advocating for me. And I'm like, yeah, okay, that's good. Let's go do that. But the mistake that I made was delegating decisions to the wrong level of the organization.
How many direct reports do you have today, Jason?
I have 7 today. We're a functional organization. So I have like engineering, I have like EPAD, which is, engineering and design and analytics, and then marketing and finance and that sort of thing. But I work with the directors and the ICs. So when we do these product reviews, I have the frontline, like the people doing the work, actually prepare usually like Loom recordings, like video recordings, and they send them to me. And I will watch like a 15 or 20 minute walkthrough of a feature. And then I'll go look at the Figma, for example, or read the strategy doc after they talk me through it in a video. And then I often respond with a video recording and I'll talk for like 20 minutes and give them feedback. And then only if there are questions do we have a meeting. And it's incredible. I have so much free time and I'm able to give feedback on so many things because I watch the videos at 2x. I can always find time to watch a video. I can respond to the video. And then these meetings where I used to have these meetings with like 20 people and we'd walk through a product. It was a 45-minute meeting. And then like everyone wants to talk. If I give feedback, people are defensive. Oh, the CEO's being, giving feedback. They want to respond to it. It's like this whole ceremony. It's ridiculous. And so now like we just cut all that out and it's been transformative.
Do you lose participation and discussion with that Loom async response?
Yes, but that's kind of by design. Like most things don't actually need a lot of participation and discussion. Like the team has done a tremendous amount of work and they're trying to get feedback from me. And the forum of a 20-person product review turns it into like this bizarre ceremony. I actually don't want everyone to talk. I want to give them my feedback. And I want to be direct and kind, but I want to give them the feedback. And then and some of it is just questions, some of it is try harder here, some of it is like I want to see another version of this. So some of that is like this is amazing. Here's the 10 reasons why I love it, But the other amazing thing about that is those videos are all public. So if you're not in the meeting, anyone can watch. Like there's a archive of me giving feedback on stuff that anyone can watch at any point. So if you miss the meeting, you're sick, everyone on the team can hear that feedback from me without having to be in the meeting, which improves the coordination cost. It goes down.
What is the meeting that is most required for the discussion, for the engagement, and could not be done in that way?
Sometimes you will have more on the. Sometimes there'll be situations where you need to have like an expansive brainstorm, where it's like we are going to explore something together, and it's not a presentation. It's not necessarily a decision to be made. It's like we're going to explore something together. So we'll get in a room, and the creativity and the back and forth. The result of the meeting is like 15 options or a wide open idea. I find that those are good discussions. And then sometimes there are discussions where, there's different points of view and it's clear that from like sort of the initial sort of presentation and the reaction, there's still things to be hashed out. And then you get in the room and you have the debate, but everyone's already done this back and forth So you come in fully loaded up on the context, and you can have a really rich conversation and figure it out in, 30, 45 minutes.
Toby at Shopify says the job of the CEO is to inject chaos into the organization. And I like that because I fucking do that. But I don't like it because I'm also like, hey, guys, we're going to do this crazy batshit idea. And then it's like, oh, that's a load of distraction. Which side do you fall on?
I have a lot of respect for Toby. I don't know that I would say my job. I don't think of my job as injecting chaos. I think my job is to make sure that we're creating amazing products for people. And if the chaos helps the organization do that, then I suppose I will inject chaos. But I think on balance, for me at least, I have not found chaos gets us closer.
Do you think the best CEOs are the best resource allocators?
Resource allocation is certainly important as being a CEO, because if you have a large group of people, the first thing you need to do is figure out like, how do you want to organize them together against what problem sets? But I do think that selecting the right problem sets is probably more important than the resource allocation to some extent. Like if you have the right problems, but your resource allocation is sort of wrong, you'll notice that and then you can correct it later. But if you have the wrong problems and then the resource allocation can't be right. So I don't know that it's like you just have to be a resource allocator and that's it.
Problem selection is down to you. It's also down to your execs. You mentioned kind of some challenges in terms of scaling exec teams there. It's a really hard thing to scale an exec team. When you think back to mishires on exec teams, what are some of the biggest lessons for you on that element?
There's two things that come to mind. One is that hiring execs is a bit tricky because by the time someone's an executive and they're interviewing for a role at that level, they're probably very good at communicating and they're very good at talking about the work. And so I have found that actually interviewing execs and very sort of more senior experienced people is really good for getting a feel for whether I would enjoy working with them. Can we brainstorm? Can we debate? Do I enjoy, being with them? But I rarely find that folks like fail the sort of capabilities test in those kind of interviews. I mean, sometimes they do, of course, but I find by the time someone gets to me, like they're sort of qualified for the job. So the thing is, you have to reference check the heck out of executives because it's really hard to fake it for like 3 years if you work at a company. So what I do when I hire execs now is I meet them to get a sense for like, do I enjoy being with this person? Can we debate and have a good conversation? And then I call like everybody I know who has ever worked with them to try to figure out what they're actually like to work with. And that's where you get the real insights. And since I started doing that, my success rate at hiring executives has gone up a lot. And the second thing is then once you get them into a company, I have like a whole process that I've sort of come up with for how to integrate them in. And the short version of it.
How do you do that? That's very hard to do.
Yeah, the short version is that I don't expect them to do any work for the first like 60 days. They come in and they just need to learn. I just want them to meet the people, learn what we're doing, figure out why we're doing things. And every day what I expect them to do, I have a meeting, I'll set a 30-minute meeting with them every day for like the first 45 days. And I want them to ask me questions about the business. Like they need to learn and understand there's so much context. They need to learn and develop a point of view on their talent, on the projects for their area. And then sort of in the second month, start to express some of that viewpoint with me. And then by the end of the third month, like they take over and they're running their team. And I have found this like sort of like learning transition really sets them up for success. Because if you expect someone to come in on day one and like run it, they don't know what's going on.
What are the biggest reasons why execs become exec mishires? How does it most often go wrong, essentially?
Well, the mistakes that I've made are actually they come in and they start changing things right away, and then the people in the team or around the company are like, "Why is this person making this decision? I don't understand why they're doing this." And like, if it's wrong, then they lose credibility, and then it's really hard for them to to get that credibility back.
How long do you give someone? Because in those cases, it's really hard. So I come in, thanks for hiring me, Jason, thrilled to join. I make a load of changes and the team's like, who is this guy and why is he making all these changes? And it's like, well, Jason, you hired me, back me, I'm making these changes. And then the culture just gets worse beneath me. I just continue to make Titanic worse inside the company, but you should back me for a while. How do you think about like how long to give versus cut it straight out?
This is one of the other things that I came to learn, which is, when we went through that period of hyperscaling, I did a lot of like, when the executive told me this is how something was supposed to be done, I would always try, I'm a curious person, so I try to understand why. And if I really couldn't figure it out and my intuition said this doesn't make sense, I would actually let them do it anyway. And inevitably, I'd say more often than not, it didn't work and I was right. And so now what I've come to learn is that, executives and other people they're experts in their craft and we should trust them. But if my intuition says that this doesn't make sense, I now trust my intuition and I won't support them in whatever they're doing. And I'll be like, I want you to do it my way and I need you to trust me. And more often than not, now that has actually worked out well because it turns out that the context of the company is so important and I have the context of the company and the executive is the expert in the craft and the context of the company, like the reasons for why you do things actually should be the beginning point to derive how you run a team or what products you build or what stories you tell, right? You think about sort of first principles, like what are we trying to accomplish is where you start, not like what are the tools for some some function or some craft. So
when did you have the strongest intuition that turned out to be wrong?
At Discord, we in late 2018, we built a PC game store, which I ended up shutting down after like 4 months. So that didn't work. There's a long list of things where I have made the wrong calls. But I think the thing that I've come to learn is that I am still more right than I am than a new executive joining my company. Like I still have more context than most people who join, given the nature of how long I've been doing this. And I also learn over time, and I think this is the trick. One of the challenges with like trust your intuition, trust your gut as advice is like you don't know where your gut is right and wrong. And so one of the things I've come to learn over the years is the kinds of things where my intuition tends to be right and the kinds of things where my intuition tends to be wrong. And so when it's one of those things, I discount myself a little bit.
I spoke to many of our mutual friends. I pretty much know all of your cap table. After 2,800 shows, you'd expect me to, so it's at least a good thing. But they said, and I hope it's okay for me to say, they said that, there's so many incredible things about you, but they said you trust more experienced people's recommendations, sometimes more than your own. And that was a weakness. Do you think that's fair? And how would you reflect on that?
I think there was definitely a period of time where that was true. And, we talked about this a little bit. It's this sort of bringing in the executive and delegating the outcome to them, but also the approach to the outcome. That was one of the hard lessons that I learned over the last few years, that is where I stopped listening to my intuition on some of these things. And as a result, a lot of things at the company went sideways.
In terms of gut and tough decisions, it's a tough decision. You mentioned earlier, like actually it's helpful when you have a little bit of money because you're not tempted to sell early. You had a decision to sell the company for $12 billion. First off, how does that feel, Jason?
It was pretty crazy
Yeah.
to be in that situation. Yeah.
Do you remember where you were?
It was not a short process and there was a lot of things going on at the time. So, it was one of those situations where I have always been very focused on just like trying to make amazing products, tell amazing stories and build a great company. And, along the way over the years, from time to time, we get interest from people and, sometimes we engage with it because like, okay, like what's happening here? And this was, it actually began as just another one of those where it was just like, okay. And, but ultimately we decided that we really just wanted to focus on creating what we're creating. I love creating software and I love solving problems for people, around gaming and having fun with their friends. And that was the path that we chose to stay on because we thought we had so much opportunity ahead of us.
The reason you sell is because you believe there's more strategic benefit to be had from the acquirer and what it does to your position as a company. Say Instagram with Facebook, say YouTube with Google. Did you not feel that was the case here?
Microsoft has been a really fantastic partner for us. And there certainly are things that we could have done together with them that we can't do independently. But ultimately, it was about controlling our own destiny, I suppose, and really seizing the opportunity in front of us.
What does no one see or think about the gaming industry in the future that everyone should be thinking about or speaking about?
We're in kind of a tough period in the games industry right now, where after COVID, it's kind of contracting, and there's a lot of consolidation. Yet it's as big. It's really, really large if you think about how much money consumers are spending and how much time people are spending and how important games are in people's lives. And I think that while it seems it's both large and also feels kind of like we're in a slump, I think in 10 years from now, it's going to be so much bigger and so much more important and so much more pervasive than it is today. Because if you think games just kind of follow the trajectory of digital technology. And it seems like, in 10 years from now, there's going to be more digital technology, more people using devices, crazy new ways that we interact with this stuff. And games are always at the leading edge of how people take advantage of and harness technologies. And so you think about, like, how is AI going to change the creative side of game development and the interactive side of game development? And it's just like, we could spend 2 hours on that.
How does AI change the creative side first? I've seen many tools that are addressing different elements of the creation process. In your mind, most succinctly, how does AI change the creation process for gaming products?
I mean, I think it's going to dramatically lower the cost to create incredible content, which means that you're going to get games like Elden Ring that are made by teams of like 20 people, not 300. And then it's also going to mean you're going to be able to have someone who, an individual person, a solo creator who will be able to make games that they can't make today because it takes either 5 years or it's just too hard. And so I think we're going to find
Do you worry about what that does to discovery? So I think that's amazing, the democratization, but with democratization comes a massive increase in supply.
Mm-hmm.
And with that increase in supply, discovery just becomes a war. And often in that case, it's just a game of who has the most dollars. Do you worry about discovery being that problem?
I think discovery is already a problem for developers. It's going to get harder to break through. But I think that it's really hard for me to predict how the world will be if there's like 10 times more games and they're all high quality. Because you can imagine when the cost drops so dramatically, the whole business model changes, the whole dynamics change. Right? Part of the challenge today is that it's hard to break through and it costs $200 million to make a big game, right? But if the costs were much lower, then you could have games where the subject matter is much more niche. And then in that world, what happens? Like, imagine if you had 20 Elden Rings and they all had different themes and they were all as good. And they, you don't need to make $7 billion from making Elden Ring. You could make $10 million or $50 million. Maybe it's a great business. So I think that consumers are going to have so much more choice and
Doesn't that lead to this like incredible unbundling of gaming, this immense personalization of gaming?
I think it could lead to a lot of personalization of gaming. People still like to play games in community, so I think you're still going to have situations where like maybe groups of friends will try certain titles, or I think we see potentially echoes of this if you look at how like video entertainment happens today, like on the streaming services. Where you have like, everyone watches, like there are shows that are really popular that no one's heard of, right? Because there's so many people who watch these things that you can have these kind of more niche subject matter shows. I think that you're going to start to see, something like that. Music is kind of even more like this. If you think about the music industry, how much content there is, it's amazing for consumers, but it is harder for the creative side.
What is the biggest misnomer or mistake that people have or think about how AI will impact the future of creation of gaming products?
I don't know if there's an obvious misnomer. I think that it's really hard to predict what's going to happen because we're in this world where in gaming, there's this concept of a fog of war, which is like, when you're playing a game like StarCraft, you can't see what's going on the other side of the map until you've been there. And so you have to kind of plan without knowing what's happening in the future. And I feel like we're in a moment in technology, and because of the nature of AI, it's sort of challenging us to reinvent so much about how we do things in our lives, that when I think about, where are the capabilities of AI going to be in 10 years? It's just like so hard to reason through what are the implications of that. Like if we actually get AGI, then what happens? I don't know. Like there's like a tech tree, and you can imagine different paths through it that could result in so many different outcomes that it's just very hard to predict. So I think anyone who's really certain about what happens is probably wrong.
How does AI change the interaction side? How we engage with these games as consumers?
Again, I don't know, but some things that I think about which could be pretty compelling are, you could imagine how today, you might play a game, like Legend of Zelda Breath of the Wild, for example, or Tears of the Kingdom, one of these big open world adventure games where you're a character and you're in this fantasy land and there's people and adventures to go on. That gets handcrafted by a team of people. And because the nature of it, it's an amazing game, but there's a lot of repetition for how the sort of structures play out because you just can't make bespoke content for 90 hours in a game like that. But you could imagine if you have AI that like every one of those characters can have a complete backstory, can respond to you in the totality of all the decisions you made inside of a game world. And you could have literally hundreds of hours of bespoke content customized to your experience that just never ends as long as you want it to go. And I think that, you know, being able to explore and play in a game world that you're passionate about forever could be really compelling. You know, you think about like watching TV shows and how it's always bittersweet when a series ends, because you're like, I'm done being in that world. It was so much fun to be there.
You get to that point where you like ration it out so it lasts longer.
Yeah. I mean, I've watched Game of Thrones like 4 times over because I enjoy it so much. Imagine if it like could never end, and it was always great.
Does that change the business model?
Certainly.
Games? How does the business model change in that world?
Again, I don't really know, but you could imagine.
Jason, you would be a terrible. I've got to interrupt you. You'd be a terrible venture capitalist. We know the future. I will tell you the future, and you will listen and write it in your Wall Street Journal article. Okay?
Yeah. Well, I think that, you know, if you think about the nature of AI and how like one of the key differences with it is, see, again, this is sort of where like, you know, if this kind of technology could run like on a device, like on a console or on a phone, then the business model might be different than if it has to use so much compute that it like runs in a server, for example. So like these details matter, but you could imagine a game like that being more of a subscription service where you subscribe to the game, kind of like, you know, World of Warcraft is. It's this never-ending story that you participate in, and by paying a little bit every month, you get to continue to explore and be part of that world. That to me feels like it could be an approach. You know, the microtransaction model probably has a place. You could potentially imagine microtransactions working there, but when everything is AI generated, you know, if all the microtransaction content is AI generated, you know, how will people react to that? If it's effectively free, you know, will some enterprising creator figure out a different way to monetize it that makes all the content free, so you don't have to worry about that? My guess is probably. So yeah, it's hard to say.
Jason, what did you believe that you now no longer believe?
You know, a lot of the advice out there for how you run a company.
Do politics have a place in the workforce?
I think that each CEO and each leader needs to decide for themselves how much they want to talk about politics in their workplace. The one thing that seems clear is that we are in a very kind of heated, divided time in the world. But I think it's up to each person to make that call.
I spoke to Danny Reimer before this show, and he said that his first encounter with you was probably his most memorable first founder encounter ever. I think he described it as an interrogation, to be quite blunt. So take me to the first Danny Reimer meeting. Where was it? What did you do? How did it go?
It's funny he calls it an interrogation. I remember I was meeting with him, and I had just read an article maybe the day before about a company that he had invested in that I think kind of went bankrupt or something. Yeah. And I wasn't raising money, but I was like, oh, I'll go meet with this guy. People say he knows what he's doing. And so we met at a coffee shop somewhere in the Mission in San Francisco. I forget which one. And, you know, I'm a pretty curious person. I love to learn from people. You know, I think that so many, you know, like there's 2 ways to learn in life. You learn from your own mistakes or from other people's mistakes. And so I love to read books and talk to other people to learn about like, what are their mistakes and what can I learn from? So I'm meeting with Danny and I'm like, well, you know, I don't know what to talk about. I just read this thing. It was really interesting to hear about a company that just went bankrupt. So I was just really curious about it. So I just started asking him questions about the experience and what happened and what did he learn from it and what did he take away from it. And you know, I have to be honest, I don't even remember what he said at this point. I mean, it was so long ago, but I remember the conversation and I know it really stood out to him.
Do you think you were a good fundraiser? And with the benefits of the many rounds you've done, what have been your biggest lessons on how to fundraise successfully?
I guess I am a good fundraiser. We've raised almost $1 billion. And I think that at some level, I think raising money when you're building a business that is growing really fast and has a lot of consumer love, it's kind of easy.
I don't disagree with you. Yeah, which was the hardest round?
So we definitely had hard rounds. Our Series A was actually pretty hard because a lot of investors, this was before we had Discord. So when we were working on our game title, this was, I think, maybe 2013. And at the time, what I was fundraising on was this vision to build a big gaming business around a group chat app starting with a game. And most people said no because they thought the game wasn't going to wasn't going to get there. So we got a lot of no's in that round, and Mitch Lasky from Benchmark said yes, and he thought the vision was exciting, and he thought we would figure it out, and so that was a hard round, but I'm very grateful to Mitch for seeing what I saw and supporting us in that. But once we got to Discord and the charts were all up and to the right, it was much easier.
Should you always take the highest price?
No, in fact, I got an offer. I think our Series A, I had one other offer for a little bit of a better valuation, but I really wanted to work with Mitch, so I chose to work with him.
Is it a needle mover having Benchmark as an investor?
Mitch has been very helpful. I haven't spent a ton of time with the other partners, so one thing that I have learned working with so many investors over the years is that it's not really always about the firm, it's about the person. So, my sense is the other folks at Benchmark are great, but I haven't worked with them, so I don't know. But working with Mitch has been great.
I heard another story I had to discuss was Rockstar Games, where apparently you walked in feeling pretty confident with bags of cash, expecting to buy a ton of IP. What happened there, Jason?
Yeah, so we went to New York. This was around the time when we were building our PC game store in late 2018. And I went to go visit with the Rockstar folks to talk to them about whether they would list their upcoming title, I think it was Red Dead Redemption, on our store. And they were very gracious folks, and we chatted with them and discussed a lot about like what their priorities were, and tried to do the normal BD thing of like what's going on over here. And what I realized as we were coming back was that the game store business at the time was such that they only wanted, basically what I realized was that we were going to have to spend a lot of money and minimum guarantees to get developers to put their games on our store. And it wasn't just Rockstar, but that trip to New York was like one of the moments where I realized that the best games are going to cost us a lot of money. In that moment in time, other people had just launched game stores as well. The PC game store industry was kind of slow moving for a while. And in that window, like Epic launched theirs, we launched one, Microsoft was coming. And I realized that to compete in this business, we were going to have to spend a lot of money on minimum guarantees on a lot of titles. And I didn't feel like it was going to really be worth it. So I decided we weren't going to spend the money, the bags of cash on that title or on any titles. And we shut down the game store 45 days later and completely pivoted out of that business, which I had just raised a round of funding off of. So I remember calling the investor who had put the money in, and I was like,
which round was this?
I don't know. We've done a lot of rounds. I forget the letter. But in any case, I remember calling them and telling him that we were going to do this, and I was like, do you want the money back? They were like, no. Keep going. We think you'll figure something out. And they were right.
I have to ask a question that is top of mind for me. I think there's a generation of incredible private companies like your Stripes, like your Starlinks, like your Discords. And the question that I have is, what is the ultimate destiny for this? Like, does it go public? Does it get bought? Does it run as an independent private company for years and years and years? I'm not saying to make predictions, any teasers, spoilers. Just what would you most like?
Well, there's a couple ways to answer this. What I like is creating software for people that is useful and having fun doing it with like a team of great folks. Like that's what I enjoy. Like I enjoy waking up every day, coming to work and like talking about the features we're building and talking to my customers and trying to figure out how to solve problems for them and then telling our story. So that's what I would like to keep doing. And then the question isn't what's the context around that? And of course we've raised a lot of money and the business exists, because we've had amazing investors and a lot of wonderful employees who give us their time. So all of those folks are expecting liquidity at some point, and I really want to give it to them. So there will have to be some liquidity situation eventually because people want to get paid rightfully. But when and how and what, that will be, we'll figure that out as we move on. But
would you like to be a public company CEO? Like, does that hold any desire or interest for you?
It's an intriguing sort of mode of operation, but I'll do it. But I don't wake up and go like, I cannot wait to be a public company and have it do an earnings call. Like that's not, the reason why I started the company. I started the company because I'm passionate about our customers and their problems, and I want to solve them.
Listen, I would love to move into a quick fire round. So I will say a short statement. You give me your immediate thoughts. Does that sound okay?
Yes.
So what book written before 1965 would you most recommend?
Winnie the Pooh.
Why?
Because it's just such a wonderful book. It's a story of friendship and fun.
Yeah, I can see why you're not an investor.
Yeah, were you looking for like Benjamin Graham or something?
Do you know what my takeaway from this episode is? Honestly, I think you are freaking great. You are such a lovely human being, but we also could not be more like other ends of the spectrum. I had a great conversation the other day, and they was like, hey, how faith impacts how you act in the world. And I responded, I have faith. I believe in liquidity.
Hey, capitalism is well, yes, okay.
don't say anything that purges you. Don't say anything.
Yeah, that's not a soundbite. We're gonna have.
No. What's the most what blog post written post 2000 other than Founder Mode is your favorite?
Yeah, I really enjoyed a series of posts by Mark Schuster. He used to write in the late 2000s. He had a blog called Both Sides of the Table where he would share his experience, and I really, really learned a lot from him.
Dude, I grew up on that blog, actually. Yeah, he wrote one piece about investing in lines, not dots, and the importance of relationships over time. So important. Completely agree. What's the most contrarian or unorthodox advice you'd have for founders listening today on any aspect?
Yeah, I think it's that if you're building a consumer product, you have to build it for yourself. It's really hard to build consumer products if you are not the customer.
Is it wrong to do it for the money?
No.
That's okay.
I think you can do it for whatever reason you want.
What concerns you most in the world today, Jason?
I'm worried about like our institutions and like civic engagement, future of education. Like there's things about the world that seem to be getting worse, and we may not figure out how to fix them. So I'm trying to think about how to help fix them.
I think education has a lot to learn from game design. You are a master. If you were to reshape parts of education in any way, how would you change education?
It's a very complex situation because of the government regulation, and obviously like it's just a big legacy kind of institution.
Don't worry, forget the legacy, forget all the bullshit. You've got a magic wand.
I think that I would try to redesign the school experience to be more about hands-on problem solving that is engaging and less about memorization. Because I think thinking about games, like people learn better by doing and through experience and repetition. And so much of what you learn in school about recalling facts is like just not actually that useful. Like even today we have Google, and with AIs in the future, like, it's going to be more about like creative problem solving and critical thinking and judgment. And these are soft skills that you do learn in school, but they don't really seem to necessarily always be the focus. So I think that's one. But on a smaller scale, I think like access, frankly, to higher education for people in America, at least, is something that is a problem. So there's a really cool startup that I'm involved in. It's actually the only other company I'm on the board of, called Campus, and they're an accredited online university where students in America can basically apply to get accepted and take online classes taught by adjunct professors from Ivy League schools and get a 2-year degree that they can then transfer to a regular school. And it's such a cool company run by this amazing founder.
Unless it is mission critical degrees, do you think university is worth the hugely inflated cost anymore?
I do think it's too expensive.
So if I were 18 and I said, I have this offer from this great school, should I take it? Or should I go and work at a startup and learn?
It's so contextual, I think, to the person. It's really hard for me to just sort of make a statement and that everyone should follow. It really depends on who you are. Like if you're turning down an acceptance letter to an Ivy League school, that means you've already figured out a bunch of things about like about some of the stuff I talked about. Like you probably have figured out some level of critical thinking and follow through and focus, and you're probably quite smart. maybe you should actually not go to Harvard and go work at a company and start, doing something. But if you're not that person, there may be value in going to a higher education to learn some of those more structured skills.
Keep this magic wand in your hand. You can change anything about the internal workings of Discord today. What would you change? Forgetting difficulties and logistics.
I've changed pretty much everything that I've wanted to change over the last year. I mean, I really skip to work every day now. I'm looking forward to just this afternoon. I'm getting a bunch of, roadmap suggestions for next year from our teams, and I'm going to go read all the cool projects that my teams are proposing me to do, and I'm going to pick the ones I want them to work on. Like, I'm really excited to go do that. 2 years ago, that's not how it worked. And so I kind of waved the magic wand already, to be honest.
Do you have recurring meetings?
I have meeting slots, but I have very few actual recurring meetings.
Do you like them?
The recurring meetings? The ones that I have now, I like. The ones that I used to have a lot of them, but I no longer have those.
That was elegantly done. I like that. Yeah, strong. Final one. In other words, I fucking hated the old ones. Final one. No, I said it. As long as I said it, it's fine. Final one for you. What is the most underrated piece of technology or advancement that not enough people discuss today, but you're excited about?
Yeah, I don't know why we don't have more nuclear power plants. Like, energy is such an important factor in our society, and we have this amazing technology that we have, for some reason, at least in America, regulated essentially out of usefulness. And wouldn't it be amazing if we just had kept building them over the last 50 years? Wow, wouldn't that be pretty amazing? So I think that there's something there.
Well, I think it's the kind of mass potential harm to surrounding areas that could be caused that prevent it, no?
My understanding from the little research that I've done is that there's actually just a lot of misinformation and fear mongering around it, and that it's actually much safer than people think, and that living next to a coal plant is actually more harmful to your health than living next to a nuclear power plant, and that they're quite safe.
You have been fantastic. Thank you so much for putting up with my prying, and I so appreciate it.
Yeah, thanks, Harry. Really great questions. It's been fun.
All right, good morning. It is currently
AI and automation have arrived.
To GitHub Copilot. So clicking this button triggers
The first time I heard about the long polling back-end design pattern, whatever you want to call it, is back in 2018 when I started researching Apache Kafka. You see, long polling is such a beautiful pattern. That is, you can turn almost any request response into a long polled request response system. But what does it mean? What is it Why are we so fascinated about this thing? This is what I'm going to explore in this episode of the Backend Engineering Disney. So first, let's actually define what polling is in computing really is. See, for most of you, if you are a native speaker, you don't have this problem, but us foreigners, we couldn't tell the difference between pulling and polling with a U versus with a O. You know, for the longest time I thought it's the same, but it's not. There's no thing as pulling in computer science. That doesn't exist, you know. Maybe someone invented it, but we poll something, i.e. we check if the information that we're about to ask about, is it there or not? You check for notification. You call an API and say, is there some data there? Is there a message for me? You know, is there a video uploaded for this particular creator? You check, and you check because you don't know if it's there or not. And the purpose of making this request is to check. And if it's there, give it to me. If it's not, then tell me that it's not there. And that is where polling become a problem. How often do we check? Every second? Every 30 milliseconds? How often? Every minute? Check too late, and you might miss a lot of videos, you know, or a lot of notification of messages. So check too often, and what do you have? You have a chatty, stinking system. Very chatty, right? Because there's a lot of networking going on. There's a lot of these small bytes that are being transferred, carrying nothing, sending requests, and coming back with empty responses, because most of the time they are empty because there are no messages. So that's a problem of what we call short polling. You might say, well, what's really the problem with frequently sending requests to check if there's something or not? They send it every second. That's the problem. You're only thinking about one client. You know, deploy it to 1 million machines, phones, apps, fridges, ovens, you know, IoT devices, all of them making a request every second. That eventually just tanks your backend, you know. And we backend engineers, we don't like chattiness. We want straight to the point. Give it to me straight. Just don't go on back. Stop chatting. Why are you doing this? Going back and forth. No. Come back. I'll tell you if there is something. This is where the pretty long polling come into the picture, and we see it clearly in and I'm not gonna mention push here because it's a very interesting pattern as well, but it has its own beauty. Push, right? Maybe we should, but I don't want to contaminate this topic with push. Push is its own thing. It deserves its own video. Let's just focus on polling right now. So what did we say? We said, well, here's the thing. Let's go back to the definition of polling. What is it? Send a request, because everything is a request response, really. Everything. It's just a request and response. Right? And if I send a request and you want to check if something is there, if it's there, i.e., whatever I do, I query the database, I check my cache, right? And then I see that it's there, I respond with the content of that message, right? Maybe give me the latest 10 messages, or give me the recent messages, whatever it is. Give me the last visited or viewed messages or not viewed, unread messages, something like that, right? That's a common pattern, right? So then, what you do is you respond with that. But then what if it's not there? There's nothing. You read every message. You don't have any unread messages. No? It's impossible to do this today in an infinite timeline because there is always something. They will find something for you. But assume like DMs, direct messages. Hey, refresh. Do you have any direct message? Do you have it? No. If there isn't any, how about the back end doesn't actually write anything to the socket, to that connection socket? Just pretends that it's building the response. That's what log polling is, right? It just waits a little bit. Because in that waiting, the client is not actually blocked, because everything these days are asynchronous, right? You're sending that pull request, right? Pull with an O, not pull request, right? And now there is a pull. How about that? Pull request. All right, that was wrong. So you pull something, and then you just move on with your life. And if you're using Node or JavaScript, you're just in the event menu. You're doing an event model, so you're doing your own thing. That waiting, you're not actually waiting blocked, right? So the backend just waits and not actually responds back to that connection with that response of empty message, but it will actually just baby at any second that a new message will come, right? And if it's a very live system, hot system, that message might come if you, let's say, long pulled for a second, 2 seconds, 5 seconds, a minute. And it's not a problem, because so meanwhile, you don't really have anything going on in that pipe, you know? Yeah, there are TCP keep alive messages just to keep the connection alive, you know, but you sent the request, and technically the HTTP model says if you send a request, you have to send a response at some point, right? That's the request. That's an HTTP level layer 7 semantic, which you have to be careful with. Middle boxes, layer 7 TLS terminating proxies might have these timeouts in place. And I had a whole video talking about the beauty of timeouts. It's just everywhere, you know? So you got to watch out for that. How long to wait is an interesting thing. You cannot wait forever. You can, if you own all these boxes in the middle, and you own the backend, and you own the client, you can have a no timeout, essentially. So say, I built my system, I know what's going on, right? But you got to be careful for the middle boxes, because you don't own those too often, right? Especially if you have like an API gateway, you send a request. Most requests will say, hey, if I don't hear back in 60 seconds, I'm going to just give up waiting, right? But assume the timeout on the side, you will wait for
Okay guys, it's been 10 hours. Goodbye. I have to go to play badminton. Bye bye. Tomorrow for sure I'll try to do 12-hour stream, but anyways, goodbye.